Good morning, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic logic gates from the subject digital electronics. And this is my flow of presentation. I am going to discuss about the introduction to logic gates and classification of logic gates and about in-depth explanation about the various logic gates. And first we can see what is this logic gates. So logic gate is a fundamental component of any digital circuits which process a digital inputs to provide a digital outputs. So it is an important component of modern electronics. It has been used in the modern computers, it is used in the modern memory devices, and it is used in the processors. So all the digital devices has been designed with the help of this logic gates. And next is the classification of logic gates. Logic gates is broadly classified into three categories. First is the basic logic gates, second one is the universal logic gates, and third one is the other logic gates. So under basic logic gates we have this AND, OR and NOT. Under universal it is NAND and NOR. It is called as a universal logic gates because other logic gates can be easily implemented using the NAND and NOR gate. Third one is the other logic gates XOR and XNOR. First we can see what is this AND gate. AND gate is called as it is mainly works based on the condition all true condition, which means that if inputs are 1, only if the input is 1, the output will be 1. If an input is 0, 0 or when an input is 0, 1, the output is not, or if input is 1, 0, the output is a 0. So the expression for this AND gate is y is equal to a dot b. So only if both the inputs are 1, the output will be 1. If any one of the input is 0, the output will be a 0. It is being employed in security systems, traffic light control, and it is used to calculate the sum and carry in a digital addition circuits. And next is the OR gate. OR gate is one which is any true. It works on the any true condition, which means that if any one of the input is 1, the output is 1. So it produces an output of 0 only when the inputs are 0 and 0. The logical expressions are y is equal to a plus b. It is used in arithmetic operations, data storage operation, it is used in the control systems, and it is used for signal processing. Next is the activity, which is nothing but riddle. The device which is being hidden behind our electronics is nothing but it is a cable. It is meant for connecting a devices. I can hear but I can't see. But I am a part of many electronic devices which is nothing but a speaker. I help to light up your room but I'm not a light bulb which is nothing but a screen or monitor. What has fastened yet no eyes is nothing but it is a controller. I carry electricity through my metal wires, but I'm not a person, it's a circuit. I'm a type of cable that transmits both audio and video, which is nothing but it is a HDMI cable. And next is about the NOT gate. NOT gate is also known as the inverters, which produces the output which is exactly opposite to that of the input. So the expression for this NOT gate is nothing but y is equal to a dash. If input is 0, output is 1. If input is 1, the output is 0. It is being used in digital circuits. It is used for data processing, signal conditioning, and it is also plays an important role in the control systems. And next is a NAND gate. NAND gate is a universal powerhouse. Both the NAND and NOR is a universal powerhouse because it can be used for implementing the other gates. In case of NAND gates, if input is it is exactly opposite to that of the AND gate. So AND gate with the NOT gate is a NAND gate. It produces output as 0 only if all the inputs are 1. Otherwise, it produces the output 1. So if input is 0, only if all the inputs are 1, otherwise it produces output as 1. Y is equal to inverted a dot b is a Boolean expression for the NAND gate. It is being used in security systems, it is used in arithmetic and logical units, and it plays a major role in encoder, decoder, multiplexer and demultiplexer. And next is a NOR gate. NOR gate is a OR gate followed by a NOT gate. So it produces the output as 1 only if all the inputs are 0. Otherwise it produces output as 0. So expression is y is equal to inverted a plus b. It is used as an important element in memory circuits like flash memory, and it is being used as an important element of the processor. And next is a XOR gate. XOR gate produces a output 1 only if the inputs are different, which means that if inputs are 1 0 or 0 1, the output will be 1. If inputs are identical, if inputs are 0 0 or if it is 1 1, it produces the output as 0. The logical expression y is equal to a XOR b. Applications are, it is used in arithmetic operations, it is used in error detection and correction, and it has been used in the data encryption. So that's all about the various logic gates. The final one is the assessment question. What output does an AND gate give if its inputs are 1 and 0? The output is 0. Well, which gate produces output 1 only when its input differ is nothing but it is a XOR gate. And NAND gate is a universal gate. Yes, a NAND gate is a universal gate. What is a Boolean expression for NOR gate, which is nothing but tilted A plus B? Explain the function of a NOT gate in one sense. NOT gate is nothing but it is an inverter which produces the output 1 only if the input is 0 and produces the output 0 only if the input is 1. So that's all about the various logic gates. We have discussed about the introduction to logic gates, and also we have discussed about the various gates like AND, OR, NOT, and we have discussed about the NAND and NOR, and finally we have discussed about the XOR gates. Thank you.